Today, we're going underground. We're diving into the hidden network of pipes and tanks that keeps our cities alive and healthy. We're talking about wastewater treatment, but forget about some sterile, boring chemical process. We're going to look at it for what it really is, managing a massive, bustling metropolis, a city of microbes.
I mean, seriously? How do you do that? That's the question a wastewater operator answers every single day. These folks aren't just turning valves and flipping switches. Nope, they are the mayors, the city planners, and the health inspectors for a sprawling ecosystem of trillions of microscopic workers. And their one job? To clean our water. So how on earth do they pull it off? Well, you do it with a very specific set of tools. It's this fascinating world that blends deep biology with some surprisingly simple math. And it's these tools that let an operator measure, understand, and ultimately control their microbe city to get the job done right.
In that toolkit, it really starts with the math. Before you can even think about managing the biology, you have to be able to measure what's coming in and what's going out. It's the absolute foundation for every single decision you're going to make in that plant.
Okay, if there is one formula that is the absolute bedrock of wastewater math, this is it, the pounds formula. This thing calculates the actual weight of the pollutants, the BOD, the solids, coming into your plant every day. In other words, this is how you know exactly how much food is showing up for your microbes to eat.
But look, a formula is completely useless without the right numbers to plug into it, right? And to do that, every operator has a few key conversions basically burned into their brain. It's the language of the treatment plant.
Yeah, these are the big ones. You're constantly converting millions of gallons per day, or MGD, into pounds and cubic feet. And trust me, this isn't just stuff you memorize for a test. This is what you use every day to figure out everything from how much your tank holds to how much chemical you need to add. All right, so we've got the math down. But how does this all help us manage the living, breathing heart of the plant? This is where we leave the pure calculations behind and jump headfirst into the world of applied biology, the activated sludge process.
So the real work, it's done by two main groups of bacteria. You can think of the heterotrophs as the fast eaters. They're the first ones to the party, and they just devour the main course, all that organic waste, the BOD. But then you've got the autotrophs. These are your slow specialists, like the nitrifiers. They handle the tougher, inorganic stuff. They are absolutely vital, but man, they grow really, really slowly.
The key to the whole operation is managing how you feed these guys. That's where the food to microorganism ratio, or F to M, comes in. Think of it like you're running a buffet. If you put out too much food, the microbes get fat and lazy. Too little, and they start to starve. The goal is to hit that sweet spot, somewhere between 0.2 and 0.5, to keep them hungry and working efficiently.
And it's not just about the food. It's also about managing your workforce's tenure. We call that sludge age, or SRT. This calculation tells you, on average, how long a microbe gets to work in the system before it's removed or wasted. This is probably the most important control knob you have, because if your sludge age gets too low, say under 8 days or so, you'll literally wash out those slow-growing specialists, the nitrifiers, before they even have a chance to do their job.
Okay, so you're controlling the food, you're controlling the population size, but how do you get a quick snapshot? How do you really know if your microscopic community is healthy, happy, and functioning well together?
Well, you do a little health check. It's called the SVI, or Sludge Volume Index. See, a healthy microbial community forms these nice dense clumps called floc, and they settle really well. The SVI measures exactly that. A good SVI, somewhere between 50 and 150, tells you everything's great. You've got a healthy, happy sludge. But a high SVI, that's your first red flag that trouble's brewing.
And that warning sign brings us to the next critical stage. Because after the microbes have done their job and eaten all the waste, you have to separate them from the clean water. That all happens in a clarifier, and let me tell you, it's where things can get complicated.
So, what's the #1 headache for pretty much any operator? It's a condition called sludge bulking. This is when that SVI number just skyrockets and your sludge turns light and fluffy and just refuses to settle to the bottom of the tank.
So, what's actually going on here? Well, you've basically got a hostile takeover on your hands. These long, stringy microbes called filamentous bacteria start to dominate the population. They don't form that nice, dense flock. Instead, they create this kind of tangled web that prevents anything from compacting. And this is usually triggered by keeping the sludge age too high or not giving them enough oxygen.
So how do you fix it? The strategy is actually pretty logical. You fight back. You start wasting more sludge to lower the SRT, which favors the good guys, the flock formers. You also crank up the air to get more dissolved oxygen in there. It's a direct response to bring your microbe city back into balance.
All right, now for another tricky problem you might see, rising sludge. This one's different. Your sludge actually settles pretty well at first, but then clumps of it start floating back up to the surface of the clarifier. It's frustrating.
The crazy thing is, what's happening here is actually a good process. It's just happening in the wrong place. Those specialist microbes are doing their job, converting nitrates to nitrogen gas. But in the still, quiet water of the clarifier, those tiny gas bubbles get trapped in the sludge blanket, and they act like little floaties, carrying chunks of sludge right to the surface.
So the solution here? It's all about speed. You've got to increase your return-activated sludge, or RAS, rate. That pulls the sludge out of the bottom of the clarifier much faster, so it doesn't have time to sit there and denitrify. You can also increase your wasting a bit to help lower the overall microbial population.
Okay, we're almost there. Once the water is crystal clear, there are a couple of finishing touches. And, even more importantly, there are some hard and fast rules that keep the operators themselves safe.
You know that denitrification process we just talked about? Well, it's absolutely crucial for removing nutrients, but you have to make it happen in the right place. It's like a two-step dance. First, in a tank with plenty of oxygen, an aerobic zone, you turn ammonia into nitrate. Then, that water moves to a tank with no oxygen, an anoxic zone, where a whole different set of bacteria convert that nitrate into harmless nitrogen gas, which just bubbles away into the atmosphere.
But listen, for all the complex biology and all the math that goes into running one of these plants, absolutely none of it matters if the people running it aren't safe. And when it comes to entering a confined space, like an empty tank, there is one number that matters more than anything else.
The atmosphere has to be below 10% of the lower explosive limit, period. You test for oxygen, you test for toxic gases like hydrogen sulfide, and you test for explosive potential. If that meter reads 10% or higher on the LEL, nobody goes in. It's a life or death rule. No exceptions. So as you can see, it's this incredible world, isn't it? This perfect blend of microbiology, chemistry, and really practical math. But at the end of the day, it's all about managing a city you can't even see to protect the one resource that none of us can live without. It's a vital public service, and it's a challenge that dedicated operators step up to meet every single day.